Today we're going to talk about solving systems by graphing. A system of linear equations is when we have two or more linear equations in the same variables. A solution to a system of linear equations is the ordered pair or point that makes each equation true. The good thing about the graphing method is that you can see the solution because exactly where they intersect is where our solution point will be. So where they intersect is the point that is shared between the two different equations. It's not the most effective way of doing it, but the first visual way, which is the first way we're going to show you, is the graphing method. So here are the steps for solving a linear equation through graphing. First step is we are going to graph each equation in the same coordinate plane. So instead of putting these on two different x and y axes, we're basically going to use either a table. You can use a slope-intercept, which is your y equals mx plus b, or you could use standard form ax plus by equals c to try to put these onto the graph and see what the different graphs look like. But you want to make sure that you're putting them on there together, obviously, because we're looking for the intersection points. Step 2 is going to be to estimate their point of intersection. Sometimes it's very easy to see what we think it is, sometimes it's not so easy, but we want to just get a pretty good idea what we think it's going to be. But keep in mind that we just think it's going to be. Then number 3 is we actually have to check that point by plugging it into the equations. Now notice I just said equations, plural. We have to make sure that our point that we think is the answer works for both. If it doesn't work in both equations, I could have made a mistake someplace along the way, and it's not truly the solution. The solution has to be an ordered pair that works for both equations. So because these two equations are already in slope-intercept form, y equals mx plus b, I'm not going to do anything different with a table, or I'm not going to do anything different in standard form. I'm just going to use what I have because it's the easiest way to graph these. You'll notice that I drawn the x and y axes. You need to make sure that you're using a nice perfect straight edge, something like I'm drawing by hand because this I have to do with the way that this is set up. So what I want to do first is I want to graph the first equation, y equals 2x plus 5. And I'm going to do it in red just so you can see the difference of the two points. So what we know from y equals mx plus b is that 0, 5 is our first point, which would be right about there. We also know that we have a slope of a 2, which means go up 2 and over 1. So there's a second point. It could also mean go down 2 and back 1 to a third point. And now I can connect the dots to create my graph. And again, doing these by hand, you need to use a straight edge so that you get a much better straight line than I just did. Then I'm going to move to the second equation, y equals negative 4x minus 1. So again, my y-intercept is down here at the negative 1, that's the b value. This time I'm looking at a negative 4 slope. So I'm going to go up 4 and backwards 1. And I'm just going to circle that just so I don't kind of cover over with blue. Then I would go up 4 again, back 1. And now I can draw my graph here. Okay? We also want to think about labeling our graphs so that anyone can look at our graph and know which one is which at any time. So I do want to make sure that I have those in here. Okay, so that's the step 1, graph each equation on the same coordinate plane. Step 2 says, tell us what you think the point of intersection is. Well, the point of intersection appears to be right here, right there. Okay, so the point of intersection appears to be negative 1, 3. Okay, I'm going to write the word appears to be. The reason I'm writing appears to be is that I need to prove it. I need to make sure that that is truly the answer to this problem. I need to make sure that both equations have that point in it. So to prove it, what I need to do is take each equation separately, and I'll again do the red one first. So I'm going to replace y equals 2x plus 5 with the negative 1, 3, and be careful that you're plugging them into the right locations. And then I'm going to follow through with regular PEMDAS because I have all numbers. I get negative 2 plus 5, and 3 equals 3, so it works for the first one. But I need to make sure it works for the second one, so don't kind of cheat it and shortchange that. So again, I'm going to plug in the 3 for the y. I'm going to plug in the negative 1 for the x, and I still have a minus 1. If I follow through, I get negative 1 times negative 4 is a positive 4, and it checks for the second one. So that would tell me that negative 1, 3 is the solution. It's important that both have that point in it. So then we come to some of our word problems or real-life applications. Systems are not easy to write because of the fact that you have lots of information in them, and the important part is trying to come up with more than one equation. Some word problems that we work on, you can put all the information into one equation. Sometimes you can't. And what you're looking on as a system is you're trying to come up with similar equations that are talking about the same topic, that can relate the same x's and y's, for example, together, but are two different equations that are covering more information than can be handled into one. So here's an example. We have a kicker on a football team that scores 1 point for making the extra point kick, 3 points for making a field goal. The kicker makes a total of 8 extra points and field goals in a game and scores 12 points. Write and solve a system of linear equations. So what we have here is we have kind of two word equations already set up for us to try to show us, but you'll notice there are two equations. So when I kind of look through the words that you see here, this one right here, the number of extra points is our x value, the number of field goals is the y value, and this one is our total number of kicks. Okay? So when I think about this, I'm trying to figure out how many of the different kicks we made. Well, based on this first one, this equation is going to equate to x, extra point kicks, y, field goals, and we know the total number of kicks. It was told to us right here. Let me kind of change that. It was terrible. It was told to us right here. 8 extra point and field goals. Right there. So that will finish my first equation. So that one just comes down to being this. But there's too much information in here, so I got to go on to the next one. So now I look at how many points do we make per kick. So again, the x is still helping us with the number of extra points. The y is still helping us with the number of field goals. And now I'm going to do an equation that is referring more to the points that one of these gets. So this equation down here is saying the number of points that this kicker is making. You have the points per field goal, which is 3, times that many field goals, the point per extra point, which is 1 times the next number of points, and when I add them together, that's where the total number of points comes in. So to build that equation, what I'm going to do is come down to this one, and I'm going to say that it's 3 points. Let's do it in the right order. It is 1 point times the number of extra points plus 3 points per field goal times the number of field goals, and this time up here we know that we scored 12 points. So this equation has the 12. And then this is our system. We can simplify a little bit more for that second one because we don't need to write a 1 in front of the x. So we could make it a little bit more simple. So let's just go ahead and just take that out. And at that point we don't need the parentheses anymore. And we can just leave that equation as x plus 3y equals 12. So from here, I want a graph. So these are actually in standard form. So I think because it's in standard form, let's leave them in standard form and make the graph. So I'm going to pause the video for a second. You can go ahead and graph, and we'll take a look at it when we come back. So here we have our graph. Couple things here before we go too much further with it. I'm going to make these go by 2's, and I am going to leave these as 1's. But notice I did only really the first quadrant, basically because we can't have negative field goals or negative extra points. So we're only going to focus on the first quadrant. So looking at the first equation, remember when this is in standard form, basically we want to think about our x and our y intercepts. So I'm going to use this arrow to block over the x, meaning x's are 0, and I solve for y, so y's are 8. So when x is a 0, y is an 8. And on the same hand, when I want to find the x-intercept, when y's are 0, x is 8. So that kind of helps me in standard form plot these two. 1, 2, 3, 4, 5, 6, 7. There's the first y-intercept when x's are 0. 2, 4, 6. There's the y-intercept when y's are 0. And then I can just connect the dots. So there's the first one in standard form. Secondly, when I look at the next equation, I want to focus on my y-intercept is when x's are 0, so that would cancel out. I would get 3y equals 12. When I divide by 3, I get y equals 4. So I would come over here, and when x's are 0, y's are 4. The next one, however, when I do y's are 0, it cancels out this whole 3y because 3 times 0 is 0, so x's are 12. So I have to be able to graph to 12, which is why I made a different scale down here. 8, 10, and 12. So remember, this is how graphing in standard form can be helpful. Okay, so this is the x plus 3y equals 12. So from this picture, it appears that this is our intersection point, and that would appear to be at 6, 2. But again, appearing to be and being is two different answers, so what I need to do is check this. So if I go to my first equation, and I'll go black just so I have it the right same color that goes with that equation, x plus y equals 8, I plug in a 6, I plug in a 2, and that verifies, so we're okay with that. Then I'll go to the red color over here, I plug in my x, so 6 plus 3 times 2 equals 12. Use my order of operations to get 6 plus 6 equals 12. 12 does equal 12. So that would tell me that we do have the right points. So we need to make sure we answer this question. So when I go way back up to the top and I find out what does the question asking for us, well, it's asking us to solve the linear equation to find the number of extra points and the number of field goals. Okay, well, we've done that, so we can just answer that. But we basically have to think about our x value was the extra points. So we did 6 extra points. And 2 field goals. And that's how we can use a system to solve that equation.